first that I have, and this is really come first. All right, my PowerPoint, okay?
Yes.
So please let me know if any or if my screen is not showing up. First activity of our PD plan. This is the introduction to the scientific explanation. My name is Brenda from the Division of Science Education, Chulalongkorn University. First of all, today is our first day. Let's get to know each other. In the chat box, please write down what is the science subjects you teach at school. Please type your answer in the chat box. Okay, I can see that. Okay. Thank you, Darin, teacher of science, biology. Thank you. Chemistry. Thank you. So, what do scientists do to develop the new knowledge? And because science teacher, I would like you to think about how to support students to think and work like scientists. Methods you are using to support students to think scientists. Please share your idea in the Padlet. I provide the link, and also you can scan the QR code here to participate in the Padlet. I also have the link in the chat as well. If you are not familiar with or not a QR code, feel free to click the link in the chat box. Okay. Is everybody going to the Padlet, okay? Thank you, Ajahn Purin, for repeating the link. The Padlet link is on the first one. You can see the https://padlet.com. You can click that link and answer to this question.
Can I ask? Sorry.
Yes, sure.
About scientists, the meaning of scientists, scientists who are as a teachers.
I mean
or scientists.
Oh, I mean the real science. Scientists do. Yes, thank you. If somebody had sent it, Okay, I think of the answer, but it does not see my computer.
You might need to refresh your screen.
Okay, thank you. Thanks. I can see it now. We've got a lot of answers about questioning and research, to ever experiment or research. Many people thought about do a lot of experiments and do research. Okay, thank you. And for many of you, you think it is important to support students to think and work like scientists as it helps students to understand the nature of science, scientific knowledge, and develop, and the factors influencing the work of scientists, getting them ready to real world, make sense of things around them, enhance their level of curiosity. Very good point. Learning how to do science helps students develop a scientific disposal question, use evidence. Very, very good point. And here are the methods you use. You use the laboratory work, project-based discussion, scientific investigation, literature research. Engage students in doing science, ask questions. Very good. So now we can see your thoughts about what you think scientists do and knowledge, and everybody shared about your ideas of how important it is for students to think and work like scientists. And you also share that they use the teaching method like laboratory work and investigation, doing research and a project. Thank you. So now I would like to share about what the scientific explanation, and are we really prepare our students have skills to create a scientific explanation or the explanation in real life like the scientists do. Today I provide you two videos. One is video teaching in her class. This is very common method at school. We use conformary, and the teachers did so well using her class by using the 5E cycle. Another one is the Rutherford experiment. In this plane, what Rutherford think and does in order to come up with his explanation about the atoms. After watching these two videos, I have the questions for you to answer. Let me overview the question first, and then I will show you the activity sheet that you and your group will answer. So in this commentary inquiry video, because it has a Thai dialogue, I will start by sharing with you in the large groups so that I can translate to you what teachers and students talked about in their classroom. And this answer when you go into your breakout room. What could be the questions that students try to answer? What data students measure? What was the answer students found out? And was there any new explanation that students construct to explain a phenomena they found in the experiment? After you answer the question about the confirmatory inquiry video, I would like your group to watch the video together in your breakout room. This is the video of Brato experiment. This is only 5 minutes long. After you watch the video, I would like you to answer these questions. And after a few videos, I would like in your group to answer what are the differences between learning with the confirmatory inquiry approach and a scientist ways to develop an experiment. Now let me show you where's the activity sheet. The sheet is already shared by Ajahn Burin. Let me show you what it looks like. Okay, this is the activity I mentioned about. After I open and explain about the first video about the confirmatory inquiry, I will put you into the breakout room and your group, please try to answer the color box. After finish this link to watch experiment in the group and try to answer the question. The green color will provide
เป็นเรื่องที่มีความสำคัญกับเราวันนี้ครูจะมีอาหารให้นักเรียนดูนะคะเราลองดูซิว่าเรารู้ไหมแล้วอาหารพวกนี้เคยกินประโยชน์ยังไงนะคะ
So she started from introducing the food sample. She's giving away the food samples and asked the students to look at the food sample and tell the class what are the nutrients in this food and how this food benefits your health.
ในขั้นแรกที่เป็นขั้นสร้างความสนใจเนี่ยเราก็จะนำอาหารที่อยู่รอบตัวเขาเนี่ยนะคะแต่เขาไม่เคยสังเกตเห็นว่าอาหารเหล่านี้มันมีอะไรบ้างรวมทั้งเราก็เอาขนมที่เรารู้ว่าเขาชอบเนี่ยมาใช้ในการทดลองพอเด็กเห็นเขาก็รู้สึกแบบนี่คือสิ่งที่อยู่ใกล้ตัวเขานะแต่เขาไม่ได้เคยสังเกตเลยมันก็สามารถกระตุ้นความสนใจให้กับเด็กได้นะคะตอนนี้เรากำลังสังเกตอาหารที่เรามีนะคะเดี๋ยวครูจะสอบถามนะเลขที่4ยืนครับอาหารที่เราได้รับมีอะไรบ้างครับ
มีขนมถ้วยครับ
ขนมถ้วย
แล้วก็เลครับ
เลคืออะไร
เลคือมันฝรั่งครับ
เลคือมันฝรั่งขนมรสข้าวโพดแล้วมีของคาวอยู่1อย่างที่อยู่ในกลุ่มเราคือ
แกงส้มครับ
อาหารเหล่านี้มีประโยชน์ไหมใน4อย่าง
มีครับ
อะไรล่ะคะ
เพราะมันมีผักครับ
ผักให้อะไรกับเราคะ
ผักให้วิตามินครับ
ผักให้วิตามินกับ
เกลือแร่ครับ
So she asked the students, what are the food samples that you got? The student number 4 answered his questions that he's got a coconut milk pudding and a potato crisp. Teachers then asked if this food nutritious. Students said yes, because it contains vegetable and the vegetable contains vitamins. Now teachers writing down the answer on the whiteboard. The answer is about what kind of nutrition in the food and where's the part of food that has that kind of nutrition. And next, they are going to start examining if the food really has the nutrition that the students think about.
ใครคิดว่ามันมีในอาหารทั้ง 4 อย่างเนี่ยจริงๆมันมีประโยชน์อย่างใช้อะไรทดสอบสารละลายเบเนดิกเคยทดสอบยัง
Now the teachers is checking with the students if the students know what kind of chemicals used for checking each types of nutrition. For example, the iodine solution is used for testing the starch in the food.
เคยแล้ววันนี้เราจะทดสอบแป้งใช้อะไรนะคะดูแล้วเราก็จะเห็นว่ามันเปลี่ยนใช่ปะคะนะเพราะฉะนั้นบางอย่างเนี่ยมันเหมือนกับจะไม่เปลี่ยนแต่จริงๆแล้วสีมันเข้มมันเลยดูยาก
Now the students are starting investigating the nutrition from the food. During the investigation, the teachers asking students what happened if the color changes, and if the color change, what kind of nutrition in the food you think.
พอเด็กได้ทดลองเองแล้วได้เห็นเนี่ยมาจากตรงไหนเชิญ
มาจากปลาครับ
มาจากปลามีน้ำมันไหมคะ
มีครับ
ตรงไหนคะ
ตรงพุงใต้ท้องมันนะครับ
Okay, so at the end of the investigation, teachers asked for the test result, and each group of students report to the class what they found, what kind of nutrition they found in their food sample, and which part of the food that made the nutrition came from. For example, the fish soup contains fat, so the fat might come from the fish, and that's the example. And that's the end of the confirmatory inquiry video. Now I would like you to go to breakout room. Talking with your friend and answer the question in the orange color box that I mentioned about. And then please start watching the Rutherford's experiment from the link I provide together in your group, and then answer all the questions in the activity sheet. We have about 15 minutes for this activity. Ajahn Burin, can you please help dividing learners into the breakout room, please? Maybe 3 group, probably.
Brenda, you have 7 minutes left.
Oh, okay.
Your time for your slot. I wonder if you should just go on to the next video, or I don't think we're going to be able to go to breakout rooms, and it'll take, I'm not sure we have enough time.
Okay, thank you. I have. Can you hear the voice?
Yep.
Thank you.
At the time he carried out the experiment, the atom was thought to be a blob of positive charge with negative electrons embedded inside it. Now Rutherford set up an experiment to direct a beam of alpha particles, which he knew to be heavy positively charged particles, and we now know to be the nuclei of helium atoms, through a very thin gold foil. The brass can in the centre of the picture contains a small americium-241 source producing alpha particles. Most of the particles are absorbed in the brass. There is a small opening producing a beam of alpha particles. They pass through a gold foil, which is microns in thickness, and they are then detected by one of the two detectors set up behind the foil. One of the detectors counts particles going straight ahead, which is the majority, and we count a rate of 2,000 per second. The second counter we can move to measure the scattering rate as a function of angle. Now, the experiment that he and his colleagues carried out was very laborious. It involved them sitting for hours in a dark room, holding a tiny fluorescent screen and looking just by eye for flashes of light on the screen. We've replicated that with modern detector technology. In its current position behind the foil, it will measure one count every few seconds. As Rutherford deduced, most of the gold atom's empty space, so the alpha particle just goes straight through, doesn't see anything, and goes through in a straight line. Occasionally, one of the particles will come close enough to the nucleus of the gold atom that it will be deflected by the electric field from the positive nucleus. If it comes at a glancing blow, it will be deflected through a small angle. If it hits it head on, it will just bounce straight back. And it's fascinating, I think, to them that this was telling us something very important that we didn't know about the very deep structure of matter. It showed that the atom had a heavy nucleus with mostly empty space with electrons distributed around it, which is exactly the picture we now have. It was also the start of particle physics. What Rutherford was doing, and what we're doing here, is taking a beam of particles.
Because I am running out of time, I will pretend that everybody finished the video and finished the activity in the breakout room. Sorry about that. So after discussion in the activity from the breakout room, I will have the teachers thinking about how different it is between the confirmatory inquiry in the classroom and the way that scientists trying to explain the phenomena. And I'm going to share the understanding of the scientific explanation from Joe's slide earlier. So the scientific explanation is to discuss an argument of how or why phenomenon occurs, and it divided into a claim, which is the answer to a scientific question. The claim relates one variable to another. It contains evidence, which is the scientific data that supports the claim, and the reasoning or a justification that shows why the data counts as evidence to support the claim and includes the appropriate scientific principles. So from the Rutherford's experiment, you can see that the questions that Rutherford might have is about the particles, how particles align inside an atom. He collected a lot of data. Some of the data that could be his evidence is the large numbers of the alpha particles emitted at the front of the sensor, and some small numbers of alpha particles emitted at the angle of the sensor. So because of the alpha particle is positive and the same charge repel each other, Rutherford came to the claim that atom consisted of the positive charged nucleus in the middle and surrounded by mostly empty space with negative charge outside. If we compare this process of making explanation to the confirmatory inquiry, it may look alike because students start from the question as well. They might ask questions like, does coconut milk pudding contain starch? And they have the evidence, the data that they found that iodine solution turned purple after touching the coconut milk pudding. And because the iodine solution turns purple when touching with starch, which means they can make the conclusion that coconut milk pudding contains starch. I'm sorry, contains starch. So
Brenda,
what's
you have about
wrong?
5 minutes.
So what's wrong with this explanation? You can see that actually in real life, to explain a real life phenomena is not straightforward like this. And the conclusion is not enough to help us understand what happened to what we observe. And we don't know the answer of natural phenomena when we start the investigation. So why do students need to be able to develop a scientific explanation? That's because in daily lives, we have questions like this. Is the shampoo I use natural, environmental friendly? Why do I feel an electric shock from the metal stair railing? How can some types of fabric make me feel cool in summer? Or more critical questions like the claim from the media, for example, is it safe to receive the new types of vaccine, or is the cosmetics can really change the skin color? So the confirmatory inquiry is not enough because it cannot help students relate all the ideas to the explanation to explain the phenomena they find. Uh, So now you can see why it is important for students to develop the understanding of scientific explanation by developing CER. In the next section, we will talk more about how can we support students to develop CER. This is the end of this first section. Do you have any question or discussion? Please feel free to ask. Okay, that's the end of my section.
Thanks, Brenda. That was very nicely done. You have 3 minutes left if you have anything you want to add.
I actually try to have people discuss in the breakout room, but 3 minutes is not enough. Sorry.
There's comments or questions from the participants. Got a bunch of thank yous and clapping. Well, I found it valuable that you really try to initially draw out our prior knowledge by asking the questions to put on Padlet. I think it's always really important to try to draw out students' thinking and prior knowledge about what they know. So it's one of my, so I really like that feature. I also liked it that you try to, again, we couldn't do the full experience because there's not enough time, but it was very obvious that you were trying to compare more traditional ways of teaching, confirmatory, versus more ways in which scientists actually go about doing their work. And I think that's a really valuable lesson. It's too bad we didn't get the thing, but I think it would have taken us another 20 or 25 minutes and we wouldn't have had enough time. But I really thought that that approach to have us compare more traditional confirmatory methods with practices of classroom situations of doing more what scientists do, I think is really valuable. So those are my comments that I observed from your presentation. Anyone else have a comment? We have about a minute left for this session. Okay, well, nice done. I'm sure your teachers are going to appreciate your work. And I look forward to coming back to Thailand one day and seeing numerous classrooms involved in doing scientific explanations. So it'll make my heart sing and allow me to live 10 more years longer. So I thank you for doing that. So let's move on to our next. You're welcome. I believe we have, where is she? I saw her. I believe Murney is next going to present, or Nora's going to present. Okay. I don't know who's present. I lost my, I lost, let me find my sheet and I'll tell you. I'm going to present. Sorry, Nora, you're presenting. Thank you.
Okay, before we start, I would like to ask, do you hear me?
Yes.
Okay, so first of all, I would like to say okay, good morning to Prof. Joe and good evening also to my friends, okay, in Thailand, okay, Indonesia, Brunei, Myanmar, and also my friends in Asia. Okay, I hope you're doing well. So right? So this is based on my micro teaching. So I will do some demonstration on the micro teaching. And before that, I would like to show the lesson plan that we're using for the Malaysian teachers teaching in science subject. So, okay, okay, wait. Okay, so let's share the slide, I think. All right. So actually, okay, can you see that? Okay, can you see the lesson plan? So actually, this is the lesson plan for Malaysian teachers who are teaching in science subject. So we are using the 5E lesson plan. Okay, so I will do some demonstration. Okay, with the title of biodiversity in science curricula, where the content standard of the learning is the classification of organisms, where we have to classify the animals by using the dichotomous key. And the learning standard is to differentiate organism using dichotomous key based on common characteristic. And the learning objective, there are two. The first one is to differentiate organism using dichotomous key properly. And the second one is to justify the importance of the classification of organisms using the CER model correctly. So actually, implementing the CER model, it is new in Malaysia, but okay, but this is based on from my experience. I tried to implement this into my class, and Alhamdulillah, my students, they can do, and then they can understand what is the CER model. Okay, so I will start in explain for the 15 minutes. Okay, so we will do some demonstration about the topic. It is the classification of organisms. So imagine that you are my students and then you have to interact with me, and then you have to do the, some of the task in the worksheets that I give it to you already through link in the chat. Where's to stop share? Right. All right. So share where we are. Oops. Okay. As I mentioned earlier just now, okay, from the objective, okay, first we learn about dichotomous key, and we have to be classifying animals based on their common characteristic, okay? And yes, congratulations to all of you. You did it very well. And now we are going to the second objective, where you have to justify the importance of the classification of the organism using the CER model correctly. Okay, so Does anyone can tell me what stands for CER, please? So Peter, where are you, Peter?
Yes, teacher.
Yes, Peter. So what is a stand for C?
I can't remember, teacher, but I remember
Mhm.
R is for reasoning and
Wow.
E is for evidence.
Yes, very good, Peter. Thank you so much, Peter. Okay, very good. Good job, Peter. Well, actually, C, I see. I think that I just saw Nathan. Nathan, where are you, Nathan? Nathan, where are you? So, Nathan, you're not online. Well, never mind, still okay. But yes, okay. Thank you, Peter, for the correct answer. So I just want to share with you the C. Okay, the C is stand for claim. Okay, so today we will do the second task. Okay, how the CER implement in the uh in the second task. Okay, so before that, before we going more further, I would like to explain it again for you. What is C, E, and R, and then what is the function for the C, E, R, okay, in our task. Okay, so for your information, class, okay, CER is stand for claim, evidence, and also reasoning. Okay, it's commonly used in science structure, okay, for making scientific argument and also explanations. And for your information too, CER is able to help you to increase your critical thinking, okay, and also encourage you to critical analyze evidence, evaluate its relevant and construct your logical arguments based on your findings, and also to nurture your higher order thinking skills like analysis, evaluation, and also synthesis. Okay, now class, for the second task, what we have to do, I already gave you the worksheets through your group leader, and it is the article. I think it is not very short or maybe not very long article. It's about the importance of organism classification, contributing to extinction of animal species in Malaysia. So class, okay, for the instruction, okay, please, please, and please. So have three, please. The first one, please, is you have to read the article and discuss it with your group members. And second one is you have to read the guided questions properly and answer it in the Canva. Okay. The task requires you to identify whether the statements belongs to claim, evidence, and also reasoning. Okay, so okay, do you okay? All right, very good. So, and the last one is, okay, for these tasks, okay, for this task, you may do it in 10 minutes. And after that, we'll discuss it with your friends in the classroom. Okay, so is it okay, class? All right, so temperature check. So what we have to do after this? First one, we have to read the article. Second one, we have to read the guided question and answer the guided question in the Canva. So you have to jot down your name on, or maybe you can jot down your group member or your group team. And the last one is you have to identify the statements where it belong. Okay, so everyone, if you're clear, I think you may start now. So this is the article, okay, for the activity. So what you have to do is you have to read it, and then you have to identify, okay, what kind of the answer is it, a claim, and then you have to put, or maybe you can cut and paste in the Canva. All right, so 10 minutes. Okay. So actually, this is the sample for the students. So you have to do it. Okay. Does any one of you know how to do it in Canva?
So I can't read this. Can you make it bigger?
Okay, never mind, doctor.
That's good. Yeah, let's just make it a little bit, people, there's a comment that it's too small to see. That's good. I can see that. Can everybody else see that?
Yes, we can.
Okay, I think this is good.
Okay. Right. Okay. Actually, this worksheet, we have to write it in Malay, but because of today is the presenting, so we have to translate into English version. Okay. And this is the sample of the exercise, first exercise. So for the first task, okay, for the first step, I have to give clue for my students to answer the question. So they have to find out which one is for claim, and then they have to copy and paste the answer, okay, into the box. And then the second one, okay, after they finish their worksheet in the group team, okay, I will go to the every team in the class to assess their worksheets. And then after that, if they're going correctly, so they have to go this one. Okay, actually you have to jot down lah, right? Okay, for my class, because of my students, they are Form 2 students, they are very familiar using the Canva, okay, in my classroom. So they just already copy and paste because I already structured the worksheets, and then they have to jot down their name, and then they have to copy and paste the answer. They have to read the task first lah, okay? And second one, okay, so this is the second example, okay, second activity, okay, this is for the enrichment for the students, okay. All right.
Teacher Nora, currently I don't
Yeah.
think we are able to edit it or do anything to it. It does require us to sign in into the something Canva or something.
Yeah. Actually, they have to sign in into the Canva, and then they have to uh, do this task. They just copy and paste. They have to read the task, and then they have to follow the guided instruction. After the guided instruction, if they are done, then they go for the second activity, okay, which this is the hard level for them. So they have to find out which one is the claim, evidence, also reasoning, and then they have to put it in the box right here, like this. Okay, because they are Form 2 students, they are not the higher university students, so they're just 14 years old students. Okay, so it's already 10 minutes, I think. Okay, so after do this activity, I will ask my students, okay, as a representative team to do the presentation, or maybe do some sharing about their findings. So, okay, so from the findings, the students may just answer the question just like this. Yeah, just like this. So they have to put the answer, okay, into the box, and then they have to present what they find out, what is their findings through the article, okay, in 5 minutes, okay. And after that, after do the presentation, I will ask my students, okay, I will ask my students what they're feeling, what they feel about what they learned today, and after that, what is their maybe their findings, okay, by using the model CER, okay, regarding to the topic. And just for temperature check, okay, as the end, before the end session, I will conclude what is the, I think, what is the conclusion of their teaching on that day. That's all.
Okay, so Nora, you're finished.
Yeah,
You're done.
already. Yes, already done.
Okay, great. So we have quite a bit. We have some time. I was about 15 minutes. So I'm just curious. Do people have any comments related to Nora's presentation?
Professor Joe,
Yes.
the micro teachings that Arinda did was directed to teachers, while Nora's micro teaching was literally directed to students. So, are we actually doing micro teachings to direct to students or to teachers currently? Just wondering.
Well, what we're doing is demonstrating a lesson that is part of your professional learning plan that you'll present to teachers. So I assume Nora was engaging us as teachers in a lot so we could understand how to do CER in our classrooms with our students. So she was engaging us in an activity similar to what she would hope teachers would do in classrooms to help us learn. And you see Nora nodding back and forth, so she agrees with my interpretation. And now you see her thumbs up. So that's what we're doing. So you can, so I thought both presentations were directed towards our professional development. Does that answer your question, Peter?
Yes, thank you, Prof.
Other comments or questions for Nora?
I would like to ask
Go
a
ahead,
question,
Brenda.
please. Nora, thank you for your presentation. I love the design of your Canva. It's bright and colorful, and I'm sure that it's attracted to your learner. From what I find myself is the difficulty. This might be only me, but for me, when distinguish the claim, evidence, and reasoning, I am familiar with the real data from an experiment. When it comes in the form of passage, I found that it's difficult for me to distinguish which is the evidence. I mean, it all looks like a claim. Can you please teach a bit more how to distinguish that?
All right. Thank you, Corinda. Right. The They are very new with this model. So the first phase is we have to introduce step by phase the CER model with the student. And after that, if the students are very familiar with the CER model, then we can proceed into the next level. So we have to do this step by step, level by level, according to the student's knowledge level. Yeah, thank you, Parinda. Is it okay?
Thank you. I just would like to share with you, but maybe this is only Thai context. Thai students are not very well when reading a very long passage. So you might not have the same problem as this, but if you do, I'm thinking about a hint or a clue that help guiding them to make them easier to get the idea from the long passage, like maybe having some sort of pictures or the highlight of the sentence might be might help to make things easier for the students. But thank you so much. I really like the idea of using the Canva for the activity.
Yes, because of the Malaysian context, we implement the digital literacy. So the digital technology is very important, and most of the students in my class, okay, even though they don't have any laptops, okay, any laptop, they can use also, handphone to complete this task. Most of my students, yeah.
So I had a similar I had a related question or comment related to what Prinda had to say. Typically, when I like the idea of if kids are going to write a scientific explanation, they need to know what question they're answering. And so I didn't see the question, right? So I don't know if that would help Prinda or not. But if there was a question that was up front, then I could be driven by looking for what's a claim from this article and what's the evidence and what's the reasoning. But I wasn't clear. And again, it could have been a translation problem, but I wasn't 100% clear. I wasn't 100% clear on what the question I was trying to respond to. So I was trying to make up a question as I was thinking about it, but I wasn't sure of the question because I would, every explanation is driven by some scientific question. And then also related to Prinda is that I think this is, I wonder if I like your idea a lot about you have to show kids a simple situation to help to introduce them to CER, right? Because otherwise they're not going to be able to do it right. But I wonder if there's a simple experience that the kids could actually collect data based on a question and then write the CER. I wonder if that would make it more meaningful to them. Because in fact, that's what scientists do. It's not related to something they read. They might get scientific reasoning. They might get scientific principles from something they read, or it might help them in their reasoning. But again, explanations or arguments are always driven by real world events. So that's just a comment.
Prof. Joe, maybe in the article I have to put some related data. Is it okay?
It would be better. So for me, if you had an article that had data that was really clear, that student could show where they could say, oh, okay. And if the article had like a question, a real clear question, like what's happening, how can we prevent the extinction of all of species, various animal species in our country? And I'm reading the article to try to find an answer to that, right? That response, that answer would be my claim. And then hopefully the article would have some data in it. And then I could use scientific reasoning to explain why that data counts as evidence to explain my claim.
All right. Yeah.
but I like, again, the idea of introducing kids to a simpler situation to get the idea of claim evidence and reasoning is really important, because I think you're absolutely correct. Otherwise, they won't know what they're doing. So I think that's a really good idea. Other comments or questions? Okay, well, I would right. So I wonder if Myrni can explain her comment to Nora, or to me, actually. Do you want to elaborate on that, Myrni?
Yes, Professor. So I think uh, because we asked the student, based on the NORA activities, worksheet activities, she just asked the student to do claiming and then evidence and also reasoning. But I think we have to give the students the reason why they have to do CAR, why they have to claim, why they have to support the claim with the evidence, and why they have to have the reasoning for supporting their argumentation. Because if we just ask the student to do CAR and then they do not know what the purpose of doing CAR, so it will um, probably the student will not understand well the activities. They just know that we have to put the claim in this box, and then we have to put evidence here, and then we have to put reasoning here, but they do not know the connection between C, E, and R. Yeah, probably the teacher may give the students the example or give some reason why they have to do that.
Yeah, I think that's a really good point, and it's really supported nicely in the literature as well. That if kids don't see a reason, a purpose, a rationale for why doing things, it won't be as they won't continue to do it, right? So helping, there's a couple of scholars, including Kate McNeil, that have written about this and have actually collected data in classrooms where teachers who provide rationales have students who can perform better than students who on writing claims, evidence, and reasoning compared to students who do not. So that idea of providing a rationale for why they're doing this is really important. And it's also been shown not only for claim, evidence, and reasoning, but also for other aspects of the work we do, that if we support kids with saying, why are we doing this? And having them understand how this is an important part of doing science and what scientists do, then we have kids, we have students in our classrooms that are more likely to engage in that practice than if we don't do it. So I think that's a very nice point that you made, that in both cases, we have to help students understand why are they doing this and provide a really clear rationale for that. Now, we as teachers don't have to do it, that we can try to draw it out from the students themselves, but nevertheless, it's really important to try to draw it out, for, help students understand what the rationale is. Well, I'm really excited. Now I can go to Thailand and I can go to Indonesia, and I will see claims. I will see students engage in doing claim, evidence, and reasoning, and how beneficial that would be to really support our students in really understanding what it means to do science and really helping them learn science so they can actually apply science to make their lives and the lives of others better. So I'm really pleased that we've had this focus on how you do scientific explanations in classrooms. I'm just going to ask one last time if there's any last comments. Oh, Malaysia. Sorry. Well, I'll see it now in Thailand and Malaysia. I will see um, I will see claim evidence and reasoning done. I'm sorry, I got the countries a little mixed up. Okay, let's go to Darren. And then when we come back, there is a comment. Let's go to Darren and then we'll finish up with some other general points of view. So Darren, I think you're going to involve us in interactions.
Yes, thank you. So good evening or good morning, good day, maybe for some of us. Let me explain first a little bit. So according to our PD, I'm going to show you first lesson from Unit 1. It means our learners already studied introduction part, just a small part of our PD. So it means in introduction part, we are going to explain them what is CER and why do we need it. So today, when I will show you interaction unit, it means they already know what is CER. They just finished CER. But since it's a first lesson, I will smoothly go from CER to interaction unit. So let's see. So good evening or good morning again, my learners. This is our agenda for today. And what was your home task? Who remember? Your home task was about CER. So who can answer what is CER? You can write on your chat box. What is CER? Claim evidence reasoning. Yeah, it's 3 words, but we already study what is CER. So who can explain what exactly what is it? Approach, technology, some methods. Why do we need CER? Why is it important?
So CR is helping us to make a scientific explanation or construct a scientific explanation.
Thank you. Argumentation on scientific explanation. We learned that means claim. It provides an explanation, answer to a question. Okay. So let's go to help students develop critical thinking. Yeah. So here we don't have wrong answer. All answers are correct. And then we will do some static electricity experiment and what materials we need: balloons, wool clothes or sweater, plastic combs, small piece of paper, silk or polyester, glass, hair. Actually, there is a 3 activity, but we will choose one, and I will show you one of it. Let's see, yeah. I have a small piece of paper. Each of you can take a paper, just cut it, divide it on small parts. Then you need a pencil. You can take a comb or pencil, go through your hair. And try. Does it attract? No. But even if it doesn't attract, it's a result. We will
It actually
discuss.
does.
Maybe for you it does, but it doesn't for me. But it's a result. We will discuss why this pencil doesn't work. I will take another pencil. Go through my hair. And you see, it works. So even if it works with one pencil and it doesn't work with another pencil, it's our results. So we can discuss why this pencil attract parts, small parts, and this pencil doesn't attract. So what do you think? I mean, all of you. The materials, materials of pencil. Use plastic rule instead of pencil to have better effect. Okay, maybe. Other comments? Materials amateur. But I guess it's two type of plastics because my pencil's made by plastic. Made of. By an error, since we know it should have worked. Do you really think so? I will try it again. They are different materials. Okay. Okay. Time taken, you rub the pencil. Huh. I will do it like this.
I don't know how, but my pencil is
Yeah,
working.
I see.
So, you know.
I see your pencil. Yeah.
Maybe it
I will
depends on the
choose.
sender.
I will. I will choose two same parts. Yeah, it better works with one pencil and doesn't work with another. It's not plastic, not an electric insulation. Yeah, maybe difference in materials. So, questions for discussion. What did you observe when you brought the charged objects close to the piece of paper? How did the materials behave differently after being rubbed? Why do you think rubbing the objects with different materials resulted in attraction or repulsion? Just a small comment. Actually, here I plan to divide on breakout rooms, but I think we can skip this part. I mean, we can discuss here. But actually, I plan to divide on breakout rooms. So your answers, please. The paper stick to the charged object. This is what we observed, right, Morni? One pencil attracted the paper and the other did not. Yes. The one was attracted. Other comments? After rubbing the ruler or pencil to hair, it started to have charge. When different object with different charge is near, it will attract that object. What do you mean by different charge? Irfan, is it correct? You said when different object with different charge is near. So what do you mean by different charge? Negative charge and positive charge will attract it. For rubbing the pencil, we didn't attract the paper. It was essential to having the paper attract. Three different charges attract with each other. Yeah, different charges attract and same charge repel. Like charge repel, unlike charge attract. Yeah. So we did electrization by friction. Can you define what is electrization by friction? So what do you think? What is definition of electrization by friction?
I'm not getting some
Can
energy.
I ask the question?
Yeah, you can ask.
Is it the student read about this theory first before they answer the question?
Can you say it again?
Is it the student is given the theory first before they answer the question given by the teacher?
Actually, our course for teachers, so we assume they know something about electrization. Our course not for students. Is it static electricity into electron? So after this discussion, I think the teacher will do some explanation first, then do the exercise or task given later. Yeah, it depends, because we plan to do some courses for teachers, for our teachers, so we think they already know it. And also, as I said before, they already know what is CER. So now we are going to go to our main part. It's working with document. I will give you a link to the chat box. Please choose one of the following questions and state your claim in response to the selected question. Provide specific piece of evidence to support your claim. Explain how the evidence supports the claim. Do you need questions? Yeah, good question from Cambodia. Different material, different interaction. So this is an example how we are going to work with our learners. And actually, as I said, we are planning to divide them on breakout rooms and give them a little bit more time for discussion. And then finally discuss about this table, what they did. Yeah, we can stop, I think. Now we can do, after that, we can do peer assessment and give some comments for each other. And I will skip this part. And then it will be some independent work. For example, we found some CR worksheet for photosynthesis. And independent work will be choose one phenomenon from their subject. Each of our learners will choose one phenomenon or some question and make a similar worksheet as it's shown in example. And then they can use it in their with their students at school. This is our just part of our plan for one lesson. Yeah, actually I finished. You are muted.
Did you now say you're finished?
Yeah, actually, yes.
Okay.
It's just
Did
an
you want to
example.
debrief the responses? What would you do with these kind of responses in your own teaching?
What can you repeat your question?
Sure. Now that you got us to write our scientific explanations, right? Our claim evidence and reasoning, how do you follow up?
I guess I don't understand your question.
Okay, I'll try it again. So you had us write these claims, evidence,
this
and
table.
reasoning. Yes, the table.
Yeah.
What's your next step?
Next step is discussion and peer assessment. Peer assessment and listening what they think about CER.
Okay, so you want to ask not about the responses, but about what we think about the value of CER?
We will discuss about these questions and discuss their claims. Then we can again go to our experiment, and also we will include some videos about what can explain in atomic level what's happening.
So the focus is on helping them develop an appropriate reasoning and not on understanding claim evidence and reasoning? Or is it on having them understand claim evidence and reasoning rather than the underlying scientific knowledge?
As I said before, they already had some lessons about CR. So this lesson is I'm trying to connect CR with the interaction unit and go to the knowledge, physics knowledge.
Okay.
The
What
main
comments?
aim here is observing some interaction activities and remembering what is CR, so connecting.
What do we have comments or questions for Darren regarding his presentation?
Out of curiosity, Darren, this lesson is supposed to be at how many hours time for, I mean, for the time frames for this one?
Actually, I showed 1/3 because just half an hour, but our lessons usually 1.5 hour mostly. So I said we are planning to divide on breakout rooms, give them a little bit more time for discussion, including after that, including watching videos about explaining what's happening in the atomic level when you do these experiments.
Okay, thank you.
So I'll make a comment. I really liked it that you tried to demonstrate an actual phenomena and then use that actual phenomena to have us write an explanation regarding a potential question that we might come up with, right? So, and at first and obviously you tried to have one material be an insulator and one not an insulator. You tried to have one material that would become charged and the other so that we could write a question maybe related to what, why some things will get charged and other things won't. So I like that you allowed us to experience a phenomena and then write an explanation based on it. So I always think it's important to have people experience science, because what you did is you demonstrated the importance of that being a critical aspect, that science just isn't about knowing, it's also about trying to explain things that actually happen in the world. And we do experience these attractions of things being attracted to various charged objects all the time, depending on what nation we live in, right? So sometimes if you're a real humid environment, it doesn't happen. But if we're in a drier climate, then we can walk across a rug and get an electric charge. If we take things out of a dryer, it can stick to us. So there's a variety of different phenomena that happen. So I like it that you got us involved in experiencing a phenomena.
We had a homework. I forget to give a homework. We are planning to give them homework after each lesson. So homework for this one will be to observe the clothes when they take from the washing machine. And I'm not sure, but do you know what is antistatic? Some liquids?
I don't know that one.
I'm not sure, is it correct or not? We call it antistatic. It's some liquids, what you put on a washing machine with, and it helps you, how to say, and it doesn't let clothes stick together.
Right. So we have that for our dryers. We have a little, it's not a liquid, it's more like a sheet that you put the little sheet in the dryer, and then it prevents the clothes from having static.
So I also wanted to add how it works, but I didn't have time. But interested, so how it works, and it can be connected to this lesson, included.
Yeah, I think it has obviously a greater attraction for electrons, right? So at least this little sheet of paper that we put, this little piece of whatever it is, it must attract electrons because in fact, when you take that little sheet of paper out of the dryer, it really attracts you. I mean, it just sticks to stuff. So the stocks won't stick to you anymore, but it will. Other comments I see Agama has her video on. Typically that means she has a comment or a question.
No, I'm just supporting our team tonight.
Okay, I have question and also comment. Thank you, Darren, for the nice class. So I'm just wondering about the table that you show us to fill in about the claiming, the question, the claiming, and or the CAR. If we found that some of the students do not do correct CER, or probably the question is not going to, I mean, the question is not correct, and then it's not answering, it's not followed by the correct CER. So what should you do, or what should you plan to do? For example, the participants do some mistakes or some wrong answer in the CER. You say that the student will discuss about the CER that you put in there, but I think the student also have what is it? Have a weakness on understanding the concept. So how the teacher will help the student, assist the student to find out the correct uh, flow or the correct CER and also the correct question.
Yeah, thank you for your question. This is the reason why assessment is important. So as I said, after this, filling this table, we plan to do peer assessment. And when they discuss and give some points, it is better than teacher says it's correct or not. For example, of course, I can say your answer is correct, your answer is not. But when they give them comments, it is better for them, like interstudying, something like this.
Okay.
Or if you mean the whole class, the whole group giving wrong answers, of course, I will need to go back to some theories about previous lessons and explain it again.
Okay. So it means that the teacher have to, the instructor have to
Monitor.
more question. Yeah, have if we do not use the assessment, for example, by just using the table, the data of the table, then probably the instructor also will assist the student by asking some more questions.
Yeah, instructor can help them to understand. It depends on group. And as I said, if nobody understands, of course, you need to go back. But we are studying our courses by chapters. So in the end of previous chapter, I will see if they understand or not.
Okay. Yeah, thank you.
Okay.
Well, let me see if any one of the other presenters or if Darren has other comments or questions they would like to make regarding what the presentations.
May I ask, Professor Joe, do you remember, if I'm not mistaken, you presented the assessment tool for CER to assess, to evaluate like how like true the not true. how correct the claim is, how the evidence is correct and reasoning. You have shown the table with the points and we learn how to assess it. Am I right? I guess we might use it as well as a tool.
But that's right. I gave you a rubric. I called it a general rubric that you could actually use to modify to make it more specific for the particular task. But it basically gave, it was more of an analytic rubric because it broke it down in terms of, you know, various points for making a correct claim, having an incomplete claim, and having a wrong claim, and then having complete evidence, insufficient, you know, not enough evidence, and some evidence, but not all the evidence, and then inappropriate evidence, and then reasoning the same way, right? Providing a full explanation. So it was an analytic rubric that allowed you to analyze it. It must be in, I can send it back to you again, if you don't have it, and if you'd like it. I think it's in our Dropbox somewhere, but I can always find it and give it to you. I also have a short article that I think some of the articles that I actually dropped into the chat box, into our Dropbox in Google, into our folder, also has a couple of articles on using the rubrics to score the assessments. And I believe Anne over the weekend dropped a bunch of articles into our Dropbox. Let me go look. So I have to sign in the Google. I wasn't signed in this morning. Oops.
Dr. Joe, I would like to ask about the general rubric, right? So, the general rubric, can we create it into, like, if we want to put 5 scales, so can we put it like 5 scales, or maybe just do the simple one, 1, 2, 3, something like that?
You can, you know, rubrics, if you want to make it a 5-point scale, it's fine, right? It's really up to you, right? Rubrics are to help you guide your assessment. And we have these things called analytic rubrics that break it down into, you know, points for different parts. Or you can also have holistic rubrics that look at it more holistically. So it's really up to you, with respect to how you like to do it. I don't, so it's really, I don't know if does that answer your question?
Yep, exactly. Yeah, thanks.
I had thought Anne had put some readings in, but oh yeah. So if you go to here, I'll show her my screen now that I got it in up. So if you go to our folder, you'll see this thing called water quality. And inside water quality, Anne has no, these aren't her articles. My fault. I'll ask her where her articles are, because her articles also explain how to do claim evidence and reasoning. And some of my articles, if you go under other readings from Joe, some of these will have it. We'll have let me see. No, none of these have it. These are more background information articles. I will make sure I put some of those assessment. I don't see, I haven't looked at here for a little bit, so I don't see the readings related to explanations. I'll make sure I drop them in here. I'm sure if I go look at the explanations, oh, here's explanation readings. So both these articles, this one, NSTA Resource Novak and McNeil Krajic, NSTA, both of these will have the rubrics in them, the analytic rubrics, and talk about how to use them. So if you want to look at either one of these articles, again, it's in Thailand. If you go to Thailand and then you go to explanation readings, you'll see these two articles that do explain how to use what the rubrics are and how to use them. So I would encourage you to go and look at either one of those. And I had thought I will ask Anne to put her articles up. I thought she was doing it this weekend, but I don't see them. Any Sure. So Prinda asks a question, or asks, I'm not exactly sure if it's for me or someone else, but I'll first see if someone else wants to respond to this. What's the difference between a claim, a rebuttal, and an argument? Good question.
It's a question for you, Joe.
Okay.
Can you please
So,
teach
okay.
us more about it? Thank you.
Sure. A claim answers a scientific question or a question, right? So I make a claim. I can make a claim that the weather in Michigan is unseasonably warm for this time of year. And my evidence is that it's February 27th. It's in February, but the temperature is near 20 degrees Celsius. And so that's my evidence. And historical trends show that in February and 27th, the temperature is more like -5 degrees Celsius. So my reasoning would be that the temperature is substantially above the norm for this time of year, where it should be based upon various weather patterns that exist. Now that's my whole scientific reasoning. But my claim is it's above where it should be, right? It's always a response to a claim always responds to a question, and it relates one variable to another variable. So my claim is, once again, it's unseasonably warm for this time of the year. So I'm relating this current time of the year to the normal temperature this time of year. That's a claim. What's a rebuttal? A rebuttal would say, Joe, one day abnormal doesn't mean anything as far as global temperature. So a rebuttal is always someone giving me a counterclaim. But again, in the counterclaim, to make it a strong argument, they would have to provide evidence for it. So claims always should have evidence and reasoning as well. But then someone can rebut my claim by presenting a counterclaim and with additional evidence against my evidence. That's an argument. So claims always answer a question. Rebuttals always give a different point of view. And when you get that one position and another position, both of which have evidence related to them, then you have an argument. Does that answer your question, Brenda?
So is rebuttal similar to argument because it's conflict with the claim for both of them?
Well, the argument's the whole structure, right? So an argument is always going to have a claim and evidence and reasoning to it. I mean, it always has to have that structure. But a rebuttal is when you're making that against another claim, right? Not everything that's claim, evidence, reasoning is an argument, because sometimes it's fairly clear, right? You're not, right? So that, for instance, we go back to Darren's point example. There's no argument about why the one attracted the ruler attracted the paper, right? There's no argument there. The ruler attracted the paper, and the reason why is because it had a charge that allowed it to track the paper. There's no argument, right? So that's an explanation. You get rebuttal when someone has a counterclaim to the claim you made, right? And that structure, the argument is, I make one claim, you make another claim. We both have some evidence for it, but we might use different scientific reasoning about it. We then have an argument.
All right, thank you. It's clearer. Thank you.
You know, so I like, and there's certainly clear, you know, people might, in the United States, which I find preposterous, people in the United States might say that we have climate change, but it's not due to human causes, right? That could be a claim. We have climate change, but it's not due to human causes, versus we have climate change and it's due to humans putting an abnormal amount of CO2 into the environment. That's an argument, right? So I make a claim, climate change is caused by human activity, versus climate change is just occurring naturally. That would be an argument. I would present my evidence that shows that since the beginning of the Industrial Revolution, we see as the amount of CO2 goes up that we produce, not that's produced by natural events, but are produced by human events. We see that, right? That's so then we get into a debate over this, as the word was used. So all these ideas, debate, claim, evidence, rebuttal, these are all somewhat related, right? But an explanation very clearly answers a scientific question and provides sufficient and appropriate evidence, and evidence then to reasoning to justify it. There's no other possible way of interpreting it. It's fairly clear. I hope that helps.
It is. Thank you.
Okay. Sure. For claim, it's the same from inference. Well, we infer a claim from data. So Nora, in that sense, a claim is similar to an inference, but remember, a claim answers a scientific question. Okay, I'm going to pay attention to the time. I again want to thank everybody who presented today. It's never easy to present in front of our peers. It's always, I'm sure if I had a blood pressure monitor on each one of you, I would have seen your blood pressure slightly go up. That's a claim. I would have to collect my evidence to make sure that's a true claim. But I know from my own presentations that I get always nervous before them. So I'm sure that you got a little bit nervous too, which causes our blood pressure to elevate a little bit. So that's my argument actually, but I'd have to get some evidence, my claim, but I'd have to get some evidence to support it. Anyways, I want to thank you all very much for sharing this. Again, today we focused all on claim, evidence, and reasoning. As I said, it would be very exciting to go into your countries and see that claim, evidence, and reasoning being used. I saw Kesra coming on for a second. I don't know, Kesra, do you have a point you want to make?
No, I sent you a file. I'm not sure if it's the one that you were looking for.
Oh, yes. You could send that to the entire group. That's at the McNeil and Krajicek
That's
article.
it, right? Yeah, okay. Yeah. I'll share that on the Google. Maybe here
Sure,
too.
I saw that, but it is on Google. It's already up there.
Okay, yeah, it's up there. Yeah.
Let me check which one it is.
I think it was like inquiry or something, right? But I check it again.
I'm just taking a look at it.
Hmm.
Yeah, this one has a really nice, it has the rubrics in it and has a variety of different explanations. Hopefully it's explained simple enough for people to understand it. So. Yeah, that's the one I was referring to.
Yeah, I will.
I hopefully tomorrow we have
another presentations, I guess.
Here and tomorrow. Do we have so thank you everybody.
Yeah.
Bye.
Thank you so
Bye.
much.
Goodbye. Thank you.
Okay,
Bye.
thank you.
Thank you, everyone.
Thank you,
Bye.
everyone.
Bye. I did that to Darren.